Andrew Vickers, statistician at Memorial Sloan Kettering Cancer Center, out on the streets of family-friendly Brooklyn. So, what's your story?
Used to live in Manhattan, partied a lot, and then I met someone, got pregnant, and we decided Brooklyn would be a better place to raise children.
While still being in New York.
While still being in New York.
All right, so your daughter, Izzy, right? Yeah. So tell me, what does she bench press?
Sorry?
How much can she bench? You know, you lie in the back, you push up the weight, you know, what's she?
What?
Well, all right, how about 5K? What's her pace for the 5K? You know, well, how much she can do the 5K?
Huh?
Oh, well, she doesn't seem to get it, so let's try and explain this using statistics. So I've got a data set here from high school runners. We've got their age and their 5K times. We've plotted out the points here, drawn the regression line. Izzy was, what, 3 or 4? So her time is somewhere between 30 and 35 minutes for the 5K. And we also got the data, again, from high school students for the bench press. We've got all the data points up here. Here's the regression line. We're going to follow it down, and Izzy could bench press, I don't know, 20 or 30 pounds, something like that. Yeah, I got the barbells. I got the barbells here. Izzy, here. These are barbells.
You want my baby to lift those?
Yeah, and then one lap of the park, like 34 minutes, once around the park.
It's okay. It's a little plain.
Yeah, so what'd you give that out of 10?
A 3.
A 3 out of 10. All right, well, this one's got a little bit more kick. Why don't you give that one a try? Here we go.
A little better.
Yeah? Well, so out of 10?
A 6.5.
6.5, all right. Now this one's a bit spicier. What do you reckon?
Oh, that's good.
Yeah?
I give it an 8.
An 8. All right, so here we go, last one.
What is that?
This is basically garlic paste with jalapeno chilies chopped into it.
Oh, no way.
Wait. The mild one you gave a sort of a 3, and a bit spicier you gave a 6.5. The spicy one you gave an 8. So I mean, this is pure garlic and chilies. You're gonna love this one.
No way.
Well, what we've been doing here is we've got a bunch of salsas. Asked some of my friends and neighbors to come over and rate them, and well, this is what we got.
Here are the results. You can see here along the x-axis is the amount of garlic and chilies in the salsa, and along the y-axis is the taste score on a scale from 0 to 10. Each of these individual points is a vote. And along this regression line, you can see that the spicier the salsa gets, the higher a rating it got. So by the time we get to pure garlic and chilies, they should love it. They should be giving it a 20 out of 10.
Well, no, wait a minute. You can't get 20 out of 10.
No, the regression line says you can.
So one thing you mustn't forget when you're doing math is that it's just math. It's not reality. And you have to make sure that your math lines up with the real world at some point. And when you're doing regression, there are 2 very common errors. The first one is called extrapolation. And that's when you follow a regression line out beyond what the data can support. The formula tells you the 5K time of a young child, even though a young child probably couldn't run 5K. The other error, give me a flip, is to assume a linear relationship between your X and your Y. Now here we're just assuming that the more garlic and chilies you put in, the better it's going to taste. But actually, you have a curve. The more garlic and chilies you put in, it's going to start tasting bad.
Okay, I think we need
So now when you're drawing a curve, you can use restricted cubic splines. Quadratic terms is another option. I think Royston There's 2 reasons why I keep on emphasizing that. The first is because regression analysis seems very complicated. At heart, it's very simple. You're just trying to get an equation to describe the world. The second reason why I keep on emphasizing that regression is an equation is a sort of cautionary note, because equations can be wrong. The equation can give you a straight line for the relationship between the amount of garlic and chilies in your food and how good it tastes, when in fact you've got a curve. And an equation can also be wrong when you extend a regression line out beyond what the data can support, when you extrapolate. And you end up saying something like a little girl can run a 5K in 35 minutes, and that ain't ever gonna happen.